Hello everyone, welcome to this second video of the series image comparison. As we saw in the previous video, we compare if two images are exactly the same. But what if they are not exactly the same? What if they have different size of some specific filter, or they are just cutted, they have some texture effect, some different color, or some extra element inside the image? How to do that? This is just you can see an example of what I mean. So this, for example, is black and white. This is the same image but with blurred effect. This has got some really strong filter, which is some burst filter. And for us human, it's easy to say yes, they are the same. But what for the computer? For the computer, we can use different methods. One is, for example, template matching. Template matching will somehow, starting from, for example, the original image, match if it's similar. There are disadvantages with template matching. For example, it works only if the image has the same size, if it's really similar, so most likely for this some burst effect it will not detect it as similar, and also it will have many false matches, so it can detect, you can, for example, decrease the ratio of quality of the template matching, but we will get many false matches. And or if the image is rotated, it will not work, and so on. In Opencv we have a really good method, which is feature detection and feature matching, which I talk about also in the video series. What is feature detection? First, we take the features of this image. Features can be, for example, corners, some forms like circle, ellipses, and blob, and so on. We take all the features of this image. We do the same for these other images. So this one which has blurred effect, we take all the features and we compare them. When they are similar and we find many of them, we can somehow detect that if the images are equal or not. I don't want to talk too much. Let's go type the code and we can discuss that further while step by step. I close all of this. So we check first we check if the two images are equal. If the three channels, as I said, they are all black, so the images are completely equal, else print the images are not equal. Now, second step, we check for similarities between the two images. And to do this, we're going to use feature matching. So feature matching, we have different algorithms. We're going to use the SIFT algorithm. SIFT is equals to CV2, I have to check, I don't remember exact, CV2 dot x features to d dot SIFT create. And to have the SIFT algorithm, you also need some extra library of Opencv. So if you just install Opencv, probably you will not have this one. I will write this on the blog how to get that. xfeatures.sift create and that's enough. Now we can detect the key points of the first image, so of the original image, key points 1, and the descriptors of the first image. A quick explanation: key points, for example, is where the feature is detected, and descriptor is some way that with numbers Opencv describe the features. So you can compare the description of the specific features of one image with the description of the other feature with the second image, and if they are similar, then we can say it's a match, it's the same feature. Key points 1 and descriptor 1 of the first image is equal to shift.detect and compute the original, and the second parameters is the mask. We don't have any mask, so we say none. The same is for the second image, key points 2 and descriptors 2 equal to shift detect and compute. I'm going to copy this one of the second image, duplicate, which is this one. I don't like to call it duplicate as it's not a duplicate. Let's call it second or image to compare, and let's put it here. An image to compare. Once we have the features, we need to find the matches. So we need to compare the descriptors of the first image with the descriptors of the second image and find if there is a match. What we're going basically to do, let's say that we have 1000 key points. So for 1000 key points there are 1000 descriptors, because each descriptor describes the key points. Of this 1000 key points of the first image, then we compare with 1000 of the second image. We compare one by one between them, and when it finds some similar descriptor, then we can say that that's a match. That feature of the first image is the same of the second image. We can use two methods. One is the brute force method, which basically, as I told you, takes each one of the 1000 and compares with each one of them. It works well, but it's really slow. In Opencv, we have the flan based matcher, which is some way to organize the descriptors so that it will make it faster to compute. And we're not going anyway to get into details about the method, we're going just to use them, flan is equals to cv2.flan based matcher, and you need to pass two dictionaries. First one is index params, and second one is search params, and we need to define them before. Index params, we say it's a dictionary. We say which algorithm we use. Algorithm, in this case we use algorithm 0. Just copy this one as it is, and trees is equals to 5, and search params is equals to an empty dictionary, as we're going to use the default value of the flan based matchers. Once we have this, we can find the matches. So matches is equals to flan dot knn match. We take first descriptor of the first image and descriptors of the second image, and we give a key number equals to 2, and that's all. Let's see how many matches we got. Print length of the matches, and I guess duplicate not defined. We got some error because I changed the name of the second image, but I didn't change it here. Image to compare instead of duplicate, and that should be enough. So I still some error, algorithm missing. Okay, algorithm, it's not with the Y but with the I. The shift sorry, the flan base matcher detected 6,704 matches. Let's show them. Result is equals to cv2.draw matches knn. We need to pass the first image, which is original, the key points of the first image, then the second image, which is image to compare, key points of the second image, key point underscore 2, the matches. Outer image, we are not going to save any other image, so we say none, and we just show it. cv2.im show result and result. And keep in mind that we are comparing the original image with a blurred image, so they are not exactly the same. And you can see all the matches that it finds. It's too big for the screen to show to you exactly, so I'm going to resize these images when I load them. So instead, let's say, actually I'm going to resize them only when I show them, because if I resize them before, we're going to lose some pixels, so the quality of the comparison will not be the same. We're going to show 3 images, result, original, image to compare. Let's resize them. cv2.resize result. We're not going to define any specific pixel. We're going to take only, let's say, 40% of the original size, so fx 0.4, fy is equals to 0.4 also. cv2.resize, let's copy it here, original and image to compare, and that should be it. As you see, it takes a few seconds to do the operation, as the images are quite big. Okay. And here you see the result. The original, we're going to compare with a blur effect image, and here are all the matches. You can see that of course it finds some good matches, but there are so many false matches. You can see that from the bridge, from the top it's going somewhere down, detecting somewhere in the sea. That's not a good match. So we need to improve this algorithm in a way that it takes only the good ones. That's why we have a ratio test, and let's see it now. Here we have the matches, and now from these matches we take only the good points. So we create an empty array called good points, and then we loop through matches, so for m and n in matches. We're going to take, let's see, the distance, if m distance. So m is from the first element and n is of the second, from the first image and n of the second image. And we're going to compare the distance. The lower the distance between these two elements, the greater the better is the match. So we're going, the ones that have big distance, we're going to not take them, only the one with lower distance. So we multiply for 0.6 for the moment per n distance. Good points dot append m and n, and here let's use only good points. Actually, expected argument. Actually, let's append only m, and here let's change, instead of draw matches k and n, let's change it in just draw matches. And this should be enough to take less points, so we can also print the number of length of good points. Okay, it was really slow, but finally it managed. Now you see that we don't have so many matches as before, like more than 6,000. We got only 371, but they are really good. You can see that they are all horizontal, so they're matching exactly the same part. So 371, it's good enough to say that the images are the same. Now let's try the same method with images with different filters. For example, here I have the image with different colors, so we can try this one, mixed colors. Let's type here mixed colors. In your case it should be faster. You can see that here we got 4,386 good matches, so really good result. Let's check some tougher one, like an old picture. First old photo. Okay, I got some. Okay, here is the result. Duplicate, and here also 2,401. You can see so that when we got so many matches, we could say, yeah, the images are the same. And we have some tougher to match. For example, this one, like some burst effect, we can try with this one. And let's see. Okay, here we got the result. Even with this, it got more than 500 matches, which is a great result. Now we are ending. Let's compare them with some image that has nothing to do with them. For example, this George Washington Bridge. By the way, while it's loading, okay, it's here. You can say 0 matches. That's how good is the algorithm. So for example, we could say if we found more than 300 points, the images are equals. Otherwise, they are not similar, they are not the same. Also, we could improve the code. For example, saying some degree of percentage, like how equal they are. If we found 500 matches, they are maybe equal, let's say 60%. If we find more than 1000 matches there equals 65 or 70% and so on. That's some algorithm some ratio that we can give as final result. And we can also detect how equal they are, like if there is some filter applied, if it's some only a portion of the image and so on. And we're going to see that in the next video of this series. And for the moment, thanks for watching.